And hello, everyone. Thank you for having me today in OWASP AppSec event. So today we are going to talk about application threat modeling tips and tricks. I'll not cover the process to perform application threat modeling, the methodology. You can refer to different standards, different methodologies to execute application threat modeling. We will just focus on some tips and tricks that could be taken during a number of stages of application threat modeling. Okay, I'll try to go very quickly in the presentation, so we have some time at the end of the presentation for any questions. So if you have any question, please drop it in the chat. Okay, so we are going to cover a number of tips and tricks related to some stages. We're talking about asset identification phase, threat modeling, scoping, application whiteboarding, threat identification and risk analysis and risk mitigations. So let's start by first tip and trick related to the selection of methodology. So there are a number of methodologies talking about how to implement application threat modeling, how to execute the process. Each one has its pros and cons. So the recommendations here is to understand every methodology, understand your requirements, the environment you have, and select which one is suitable for you. Number of methodologies could be used to execute application threat modeling as one-time activity during the design phase. Others maybe could be utilized to be part of an ongoing process of application threat modeling in your organization. DREAD, for example, could be used for the risk analysis phase of threat modeling process. So it's good to have understanding for each methodology and to try to understand exactly the requirement, the needs in your environments to select the suitable one for you. Great. Next step related to when to do application threat modeling. Number of frameworks talking about application threat modeling as part of the design or architecture phase. This could be Digital Touchpoint, Microsoft SDL. So they are mainly talking about during the design and architecture phase, you do application threat modeling, identify all possible or potential threats. And then in the verification phase or testing phase, you go and ensure the recommended controls, the mitigations already taken or implemented during the development phase or implementation phase. So this is a standard way to do application threat modeling. You identify all possible threats and then verify the implementation of the controls. However, based on the environments you have, sometimes the application threat modeling is an ongoing process. That means you do application threat modeling for application, identify a number of threats. However, you still get some feedback, get some inputs from different security gates during other stages of life cycle. That could be STAST, DAST, penetration testing, maybe threat intelligence, whatever security gates or security controls you have, you may get some other identification for extra threats that require some sort of modeling and identification for the mitigations. So you can recommend and ensure those mitigations already implemented and the application is secured. So again, threat modeling could be as standard way to be in the design phase for your application, or you can utilize them even in other stages. Sometimes the penetration testers, they do some sort of threat modeling for a specific function during the penetration testing, so to understand exactly the connection flow as a sequence here, so they can expect there is some sort of threats here that could be exploited. Okay, perfect. Next section, we'll talk about some tips and tricks related to the scope. This is one of the most important topics today in this talk because the scope is very critical. Sometimes the application threat modeling scope will focus only on the application layer. That means we are talking about some vulnerabilities in the source code, maybe to issues in the configurations for the application. So the recommendation usually to protect the application from attacks like OWASP top 10 or any similar threats. So this is okay. However, based on your scope, you may include other layers. You need to consider some threats to other layers. Maybe you need to consider some threats related to the infrastructure, the operating system, maybe to the virtualization if you have. Maybe you have some sort of Docker images that managed by Kubernetes, so you need to identify some threats related to the other layers within your scope. At the end, those layers could be source for extra threats that you may miss if your scope is just in the application layer. In general, if your scope will be just focusing with the application layer, the code, the integrations, back-end, front-end, other external entities, you need to be sure that within your organization, other domains or other layers, the threats or the risk for other layers already identified by other activities in the risk management process in the organization. This is an example. If you have managed service for any type of managed service like IaaS, PaaS, SaaS, whatever, based on the type of service, you control or you manage part of the infrastructure. In this case, the threats related to your scope you have to identify, but the threats related to any component managed by the service provider, it is the responsibility for the service provider. However, the business risks or the non-technical risks still in your scope. Even if you have SaaS service, still some other non-technical threats could be identified, maybe something like compromising the cloud admin account, something like access management, something like other requirements. So again, just focus on your scope. Ensure if you exclude any layers, it's already managed by other risk management process or any other third party. And never forget to include or identify business risks or business threats for non-technical issues. Great. So the next section for asset identification. Okay. So as per ISO standard, there are two types of assets. We have primary assets and supporting assets. So the primary assets, we're talking about business processes and information assets. There are a number of other supporting assets. The recommendations here, just focus on the primary assets. Don't waste your time to identify any other type or any other options for the supporting assets. Focus on your application, understand application objectives, go and break down the application services for each service. Try to have the processes related to each service, and then you can do some sort of mapping between the application service and the information asset. We're talking about application threat modeling, so most of the assets will be related to the application layer, something like user session ID, some sort of information asset for a specific data store you have, database or file server or whatever. So it depends on the functionality of your application. You need to identify all information assets in your application, some description, and maybe you add some asset value. You can use whatever framework to evaluate or evaluate the assets, maybe like CIA or any other options for asset calculating the asset value. It's important to have the asset value because in the risk analysis phase, we will use the same input to ensure we have accurate risk analysis process. So again, you identify each information asset in your application, you map the information asset here to the application service. We have a registration service. We have some sort of application function that provide specific application service. You need to break down all processes, and for each process, you map the information asset. Great. So the next is application whiteboarding or decomposition. Before going to this section, let's talk about how to present your architecture for any application. There are a number of standards to write or draw or implement or document the architecture for any application. One of them is 4+1 model that comes with 5 views: logical view, implementation view, use cases view, process and deployment view. Each one provides some information related. Logical view mainly for functional requirements. Implementation view, we are talking about some inputs, some information related to the developers or programmers, the software components, how they should integrate together. This is an example of implementation view. process view, this is important as well. It's provide details about the internal processes within your application components. Deployment view, again, it's important as well. So we are talking about how the application is deployed within the infrastructure itself, and also the deployment of the application on the same server, where you have some sort of directories here for file upload, you have some sort of access control required here for other features. You may have some sort of layer of virtualization or Dockerization here. So you need to understand the deployment view from infrastructure perspective and from the same server perspective. Again, your understanding for such information is important in order to identify the real application threats in the next phase for threats identification. The next view is the use case view. It's also important. During the threats identification, we'll go through any discovering some potential threats related to the logical attacks. So it's very important to have the use cases and to think about some of abuse cases for each use case. Again, this is the best model or best views that could be documented in order for anyone, regardless of security, to understand the application functionality. Here, we are talking about pure application architecture. There is no security as in this step. So during the application threat modeling, you need to understand each of those views. You need to understand exactly how the application is running, the implementation view, the deployment view, some information about the use cases, the functionality in your application, in order to identify the threats. So if those information is not ready, there is no clear documentation for that, you are not able to have those information. In this case, you need to whiteboard your architecture. So whiteboarding the architecture is an optional phase. If you have understanding for your application, you understand everything, especially if the application is small or you are doing some sort of threat modeling for only small change or minor change in the application. Sometimes you understand exactly, you have full visibility, you understand everything. In this case, no need to have whiteboarding. If you feel you will identify all possible threats without need to draw to the data flow diagram. Our recommendations usually try to do data flow diagram as much as you can, as long as you have some time, and data flow diagram will give you more insights, more information about the application architecture deployment, where this will help you to identify more threats. So when you are going to whiteboard your application, there is no standard way to have data flow diagram. This could be the common way to draw the icons for data flow diagram. It's compatible with Microsoft SDL notation. You can use some automated tools like Microsoft Threat Modeler, like Threatgile, or any other tools, or you can do that manually using OWASP Threat Dragon. I highly recommend this tool, or any Microsoft Office tools, or any other tools that could help you draw data flow diagram. Okay, so what are the tips and tricks here? The first is communication. Communication is the key. So during data flow diagram, you need to understand everything about the application. Understand everything about the application in the way you could identify all threats. You will not miss any type of threat in your application. Sometimes you collect some documentation, but most of the documentation could be outdated. Maybe some in the agile environment, you may miss some important information in the available documents. So communication is important. For application threat modeling activity, you need to get some information from business owners, from design and architecture team, from the development team themselves, from the deployment, from the DevOps team. So try to communicate with different stakeholders to have full visibility, full understanding for the application before starting the threats identification phase. Usually we start by collecting the documentation, try to have high-level understanding, then schedule first stage of interviews or meetings with number of stakeholders, draw data flow diagrams, draw everything, understand the mapping between each data flow diagram and the information assets, then schedule another meeting to confirm and ensure our understanding for the application. Perfect. Other tips here related to how depth you need to go during the data flow diagram process. This is an example of data flow diagram. You can find it in some tools. You can see here there is client, Angular, JavaScript. There are a number of processes here. This is okay as the high-level data flow diagram, and this is okay also if you will understand everything about the application based on that. So data flow diagram in general, the activity, it should be executed just to help you understand the application and identify threats. But sometimes it's recommended to dig deep in some processes and have some extra details. Those details or those some depth could give you more understanding for the application component. For example, here we're talking about client using Angular JavaScript. This is client-side code that may include some processes. Those should be identified in the client side. The same for authentication service. Authentication service, you need to have some details. How is the authentication is going? Maybe there is some sort of OTP here, the integration with maybe other systems for Active Directory integration or external, with how to manage the session management after the authentication. Some details is required here in order to ensure all threats against the authentication feature is considered. Here is another example of high-level threat modeling data flow diagram. We're talking about application server, SOAP service, data store, very high level. Yes, this is another example, very high level. So web application, data stores, background worker processes. Again, it's okay as long as you have enough information to do threat identification. Okay, so let's go on an example of what are other processes could be identified. This is an example of client-side code. Whatever React, Angular, JavaScript, whatever client-side code, you need to identify some internal processes within the client side. You are talking about a browser where most of data flow diagrams draw the browser like external entity, and that's it. If you have some client-side code, you need to go and draw the processes that could be implemented in the client side, especially if you have some integration from the client side. Let's have this an example. There is some sort of payment with maybe Visa or MasterCard. In this case, within the client side itself, there is communication with the back end to maybe gather some information about the payment, but the payment itself is from the browser to the payment gateway or Visa or MasterCard. So in this case, there are a number of threats could be identified in this step that require more details in high-level design or a data flow diagram in order to have full visibility, full understanding before going to the threats identification phase. Another steps related to the using of microservices in your environment. So whatever microservice the code application itself is implemented based on microservices, integrated with API gateway or not. So usually, if your application is built on microservices, the microservices will be the core of any data flow related to any application service. So whatever application service will utilize some processes from one or more microservice in your application. That's why if you are going to draw data flow diagram, you may use the microservices as the core, and then based on the environment, maybe there is some sort of integration with API gateway, and this could be the layer to integrate with some external entities. Most of the microservices sometimes actually is linked with specific data store. You need to highlight those layers as well. So for each data flow diagram, you need to understand the processes in the client side, the communication with the back end. If you're using microservices, identify microservices, make it the core in your data flow diagram, where some processes will be utilized based on specific data flow for specific application service. One more thing related to some processes that could be integrated with different processes in your data flow diagram, like logging, for example. In this case, you can make it easy just to have some sort of vectors there where you collect the logs from different processes and communicate with external entity like SIEM solution. So this is just some recommendations to draw data flow diagrams for a different component in your application. It's not mandatory at all to go in such depth to have data flow diagram. It's just recommended in case you need to understand more about how the application is running. And then this will be very helpful if you need to go the next step where you need to identify threats here, there, and there. It's very important to understand everything. So if you can, without doing this detailed data flow diagram, it's okay. If you need to understand more, data flow diagram should include some extra processes where you understand everything. In the next step, you will find it more easy to identify some threats, especially the logical attacks. As you can see, some inputs here coming from the logical view, some from the processes view, and others from the deployment view. That's why the 4+ model is important. Actually, you don't need to use 4+ model. Any application architecture model will provide you with the required information about the logical, the processes in your application, and the deployment, and even the use cases. Other type of drawing your application using call flow, connection flow, or sometimes called sequence flow. So in some cases, you need to have some sort of sequence flow for specific function. I cannot say this is mandatory for any application function. It depends in your understanding. If it's clear for you based on data flow diagram, that's okay. In some cases, okay, there is some sort of integration here with internal entity, and there is some sort of payment going there, and there is another one is integrated with some sort of user identification database. And from data flow diagram, you still cannot understand, cannot guess how the sequence is going from the client and backend server. Sometimes it's good to have connection flow for specific function in your application to understand more. Most of the penetration pen testers, during the penetration testing, they need to understand some sort of request response for specific function. They draw some sort of very quickly a connection flow so they can identify some threats or some vulnerabilities could be exploitable. Another type is the logical flow or the logical steps for specific function. It's also one of the ways that you may use to draw some functions to understand the logic. This is also important, and we will go for the same steps here during the threats identification where you are going to identify some logical threats. Another tips for drawing data flow diagram, try to draw data flow diagram where they will be understood by software developers or architecture team. Try to make it MVC model so they understand how those are processes in the controller, those are in the model, maybe those in the views. Try to make it in layers. So those are the processes in the client side, those are the process for shared services. Here there are some external entities, third parties. Try to make it easy for anyone to understand. Why it's important to have in such case? Because data flow diagram, it should be reviewed with the development team, architecture team, with other stakeholders in the environment. So it's very important to have this data flow diagram understood by them, so they can highlight, okay, no, this process is not, you are using another type of services here or another type of connections here. So also it's very important to have the data flow diagram layered and easy to understood, because in the future, during any change in the application, you already have you have identified all application services, processes, and data flow diagram for each application service. So in the future, in case there is any change, you can just ask the architecture team or any stakeholder in your organization, just please highlight which data flow is impacted in this change. So instead of doing threat modeling again for all the application, you can just focus on specific data flow diagram or specific feature in your application to threat model any application threats. And also it's very helpful for the static analysis, dynamic analysis, penetration testing, whatever security gates you have, to be just focusing on this change in your application. It's very important to have the application threat modeling, or sorry, the application data flow diagram in a very easy way to understood by anyone in the environment. Great. So next tip related to threats identification. Actually, this is the most challenging step in threat modeling. You understand everything, understand the application components, the integrations, the deployment, everything about your application. And then now it is the time to say where are the threats in your application. Sometimes you go, okay, I need to identify some threats. Let's have OWASP top 10. Let's have whatever application threat library. And let's, okay, there is possibility for SQL injection. There is possibility for whatever threat in your application. This way may be good, but you may miss many application-specific threats. So how to go in this process? Our recommendation is to go in different directions. First, try to have the attack tree, understand the attack objective, understand the possible attack objectives, threat objectives for your threat actors. Understand your threat actors actually first. This is important, and then try to draw attack tree for all possible or potential threats against your application. Then for each application or for each attack tree, try to use threat libraries, vulnerability libraries, even some mitigation or controls libraries that provide some controls against some threats, so you can check those threats. So use threat libraries or vulnerability libraries after you identify the attack tree against your application. Then try to understand the use cases, and for each use case, try to think about one or more abuse cases against your application. So you can use one of the attack trees. This example from the PASTA methodology. In the parent node here, this is the threat objective. In the underlying nodes here, this is the target, the component in your application, and subsequent layers here are the where you can use application threat libraries to build all possible attacks, threats against your application. What are threat libraries that you can use, or vulnerability libraries? OWASP comes with different projects that you can use. OWASP ASVS, highly recommend. It comes with too many threats or too many domains that you can discover, or you need to check. OWASP testing guide, different projects based on whatever type of application. However, even those doesn't include everything. So some of the frameworks or the libraries built from attack perspective, like Stride from Microsoft, like whatever other methodology, and others from defensive perspective. All of them are great. However, you need to identify the application-specific vulnerabilities or threats. This is another example of threat library. It's from Autodesk Continuous Threat Modeling. So they have different domains, and for each domain, they identify some questions for each domain, where you can try to answer those questions based on your understanding for data flow diagram, and try to think about attack trees or attack vectors based on those domains. Microsoft comes with the Stride methodology. Stride is good, but you need to understand what is Stride. Stride is to identify some threats by classifying attack goals. That means it's more to attack categorization, but you cannot say Stride is threat library or a vulnerability library. So they define some attack goals, and you can do some sort of mapping. Okay, I have data flow diagram. There is possibility for tampering here. There is possibility for spoofing here. There is possibility for the denial of service, maybe add some entry points here. So based on your understanding, you just highlight which area that include maybe some sort of threats based on Stride. Again, Stride, it's not threats library or vulnerability library that you can use just to have list of all threats against your application, but it's methodology that you can utilize during the attack tree identification or threats identification. Okay, so what are the tips here? First, build your own application-specific threat library. There is no static list of threats. Each application, based on the functionality, they may come with some custom threats that you need to identify based on the logic of your application. Let's assume you have application that utilize GPS location for authentication. For example, some HR applications is doing there now. So you just go to a specific place to authenticate with the application. In this case, some sort of GPS spoofing threats could be one of the threats against your application. You will not find something, it's GPS spoofing in any of those libraries like OWASP, ASVS, or INA standard. You may find some categories related to authentication, or some details about some recommendation that maybe give you some insights about such threat. However, you need to understand the application functionality, and based on the functionality, you identify application specific threat library. You can go threat through the same process of attack trees and threat libraries after that. Other inputs are from the internal and external integrations, very important to understand the deployment and the integration model. So you understand or you identify possible threats or potential threats from internal and external integrations. Dependencies, third-party libraries are important. 4+ views, again, try to understand about the logic for application, try to understand the processes in your application, the deployment model. The other views, they may come with new threats that require some analysis. DevOps tools, they have another threats, internal, external threat intelligence. Threat intelligence is very important as well. Threat intelligence from internal, that means from different internal analysis of threat modeling, threat intelligence feeds, based on some internal monitoring and activities, and also from the external. Those feeds may provide some sort of attack tree for specific actors they are targeting your organization. So if you have such input, you may understand, okay, this attack tree or this actor, usually they are doing 1, 2, 3, 4. One of their activities is to do some sort of try to attack the application by this way. In this case, you may discover some threats that require some modeling, or you may understand the way of specific attack vector and then you focus to add extra detection controls based on your understanding for the threat actors. Threat intelligence is very, very important source for threat modeling. The same for penetration testing, vulnerability assessment, whatever activity, security gates in the organization, they may discover some threats extra. So if the threat modeling is an ongoing process, you may get some feeds from different stages. Automated tools, some tools comes with threats analysis in automated way. Those, there are a number of tools there to make threat modeling, like Microsoft's threat modeling, like ThreatGile, like Threat Modeler. Just take care about some false positive they provide, and also be sure sometimes they will not discover some logical threats against your application. Don't miss non-technical threats. It depends on the scope. If your scope is just pure technical threats against your application, you just focus about that. But if your scope will include other non-technical threats, then you need to identify those non-technical, like segregation of duties, access control, like backup, redundancy, whatever non-technical issues in your application. Those comes with some threats. They may impact the application, and you need to identify. Again, based on your scope, you may exclude some non-technical threats, and maybe those could be handled by other risk management activity in your organization. Perfect. So next step related to identifying some flaws or threats against related to the design and the logical issues in your application. So there are a number of any references that you can use. There is book about avoiding the top 10 30 design flaw. They identify like 10 domains that require some review during the threats identification. Some issues related to or some threats related to the design phase could be identified in the same way. Actually, there are a number of references there. There is securing software design is hard. This is like blog post. Also, it comes with 13 domains related to the design issues that could be reviewed during the threats identification. That may comes with extra threats that require some sort of extra mitigation against your application. Logical threats, most challenging threats to be identified. Logical threats, there are two types. We're talking about how to bypass some enforcement of some of the business logic, and this is something like, okay, so for specific functionality, there is a process to execute this functionality in your application. You need to go in this step, and there is a requirement to do 1, 2, 3, 4 before going to the next step. So you understand the logic for your application, and then try to identify some issues, some logical issues to maybe bypass some steps, maybe you to execute extra add some sort of steps extra to bypass some controls. Another type is to bypass security controls against implemented in your function or your logic of your application. So if you need to do some functionality like money transfer, you cannot do 1, 2, 3, 4, 5. If you have some parameters or some criteria, it's prohibited to do some sort of application functionality. So the security controls there, you understand those controls and try to bypass such cases. Focus on authorizations, focus on exposed APIs in your application. Any logical threats are challenging. Try to list all use cases in your application, and for each use case, try to list one or more abuse cases for each use case. This will help as well to discover some logical threats. Using logical data flow or logical flow for your application, they may give you some insights about, okay, I can do some sort of skipping this step, I can do some logical threads here. So also it's maybe sometimes it's good to have some logical flow for specific function in order to identify some logical threads. In the agile environment, we have some tips here. Executing threat modeling in the agile environment, sometimes it will be executed based on the sprint. So we have sprint here that requires some changes. We do threat modeling for specific sprint. Next, another sprint, we do again some threat modeling very quickly for this sprint. But during the release, after you need to go to the release, we discover, oh, we didn't do some sort of threat modeling to some integrations issues. Sometimes we do threat model for one sprint, and without understanding the design change based on previous sprints. So the recommendations for agile environments, try to understand the design changes for during the sprint, during the previous sprints, if you are going to execute threat modeling for your sprint. I mean, now you are doing threat modeling for a specific sprint, and you don't just focus on this sprint. Try to understand the changes in the design in the previous sprints. Okay, so you may do some sort of threat modeling for the previous sprints in order to identify exactly all threats in your sprint. Threat modeling as a code is there are a number of tools they trying to provide such features. They comes with like API that you can script and call those APIs, provide some scripts that will automatically draw data flow diagram, and then they automatically analyze the threats, provide some inputs also that could be using script to parse and ensure that there are a number of controls based on these threats, based on those discovered threats. I cannot say they are matured enough now to be integrated directly in your application. If your DevOps requires some sort of automating even threat modeling, try to have like POCs, like to test those tools. I expect they will have some limitation to identify some logical threats. You can use them as an ongoing process for DevOps or your pipeline. However, you may consider some manual steps to identify some logical, some issues related to the design flows and so on. Okay, great. So next step. Okay, so after you finished the threats identification, you need to have the threat traceability metrics. So why it's important to have those? Because don't just list all threats without understanding the attack tree. Okay, it's very important to link any threat with attack tree, with how this threat is impacting your application. There is possibility for cross-site scripting, for SQL injection. Don't just list them. Okay, this SQL injection may impact your application in this way. This cross-site scripting could be exploited by 1, 2, 3, 4. So it's highly recommended to understand the threat traceability metrics: who, how, where, and what. So in order to first to identify threats applicable on your application, and also to recommend very specific controls is implementable and understood by the development team. So it's very highly recommended actually to have such threat traceability metrics. Again, it's not a mandatory step at the end. Our objective is to identify all threats without missing any threat, and in very quickly based on the agile environments we have now. So any extra steps are required if they will add more threats. If you see there is no need, skip those steps and just go directly and list all possible threats. Perfect. So the next step and track related to understanding threat agent. Those are very important. This is very important as well. So if you don't understand the threat actors targeting your organization, targeting your applications, you may miss some very important threats. It's very important to understand all possible or potential threat agents, maybe from internal insider attacks against some infrastructure components. Maybe there is some exposed API there that could be utilized. Don't just say our threat agents are authenticated user, non-authenticated user, anonymous user, and that's it. Think about some other threat agents coming from integration with third parties, with internal, external entities, based on access for different components related to your application. Again, each threat agent will come with extra threats that should be identified. But don't list anything. So in case there is some sort of threat agent that will not bring any more extra threats, just skip this or try to group some threat agents together. Threat intelligence is very important as well, to understand the threat actors against your applications, especially to understand how they attack, or usually how they use their attack scenarios, how they exploit some application functionalities during their usual or their process for any threats, for any exploitation scenarios. So it's important to understand that. Again, this is important to highlight some extra threats, and also you may add extra detection controls in your application based on that. Great. So next step related to the risk analysis. I try to go very quickly. We have maybe 5 minutes. Risk analysis, and now you have everything about your application to identify the risk analysis. Very quickly, it's important to use whatever methodology, but you understand the perspective or the how those methodology are implemented. So in general, we have some aspects in the risk analysis, how you are going to do risk analysis, whatever methodology you are using, qualitative or quantitative, maybe hybrid, asset-driven, vertical, horizontal. That means sometimes you do threat modeling based asset by asset. I mean, so I'll go to identify some information, like application asset here, this database, for example, and let's try to have all list of potential threats against these assets, regardless of the application service or the business process. So you may go asset by asset. Usually we go in the upper layer and identify application services, processes, and for each process, the related information assets. This is very important. Highly recommended actually to go and identify the services. This will help you during the threat identification phase to build your attack tree, not just based on asset by asset. Propagation, non-propagation, it depends on the threat modeling activity you are doing. If it is an ongoing process as part of the risk management, you may propagate the risk analysis. That propagation, that means, okay, I have SQL injection here, the risk analysis, this is, for example, medium risk, and after some activities, we have another threat related to like misconfiguration of database or access issues or whatever. That means this will impact the previous identified threats, and the SQL injection maybe becomes high or critical. I don't recommend doing that if you need to finish very quickly, and if this is executed in the design phase, just go and identify threats. Don't propagate to avoid wasting time. But if it's part of an ongoing process, you may propagate some risk analysis activities to ensure your risk analysis is accurate for different identified threats. Perfect. So we have now analysis. Some methodologies that could be utilized here. Whatever methodology, it's not mandatory. This is what I am using usually. Methodology based likelihood and impact. whatever methodology that based on likelihood and impact will give you the same, where you can use to have the risk levels. Perfect. So, okay, so the final step and the objective of threat modeling is to identify the required controls against your threats. So next section is going to, we're going to talk about some threats mitigation tips and tricks. Before going on that, you need to understand the mitigation strategy in your organization. Sometimes based on some scenarios, based on some threat types, the required control cost and other staff, some controls require some time to be implemented in the code. You may transfer the mitigation to another layer like web application firewall, or even transfer the whole process to any third party. You may avoid some parts. You may, again, so understand your threats, understand your environment, understand the cost of the control. You may use the mitigation strategies in your organization to transfer or avoid instead of reducing the risk in your application. So let's very quickly go through some tips related to the controls that you are going to recommend. Try to make it practical and implementable, not just list all possible controls. Sometimes security guys, okay, I feel good if I have list of all controls in the application. Try to understand the application components, the development, the implementation view that we talked about in the beginning of the presentation, to recommend something that is easy to implement and applicable in your application. Don't say, okay, there is SQL injection, you have to use parameterized query. If your application is using some user input to control the table name in the SQL query, there is no way to use parameterized query. I mean, try to provide some controls is related to your application, applicable, implementable, understood by your development team or your internal stakeholders. Understand the business requirement and the cost of the control. Again, cost, that means time and maybe money. So understand exactly how to implement this code. Sometimes if you need to implement some controls, this will require some huge time. So instead of just going and recommend any control, understand the business, understand the cost, try to focus to provide controls within the application. Avoid as much as you can to recommend the mitigation for any vulnerability or any threat based on extra controls in other layers. Okay, try to implement the application in the way they protect themselves. One control can protect against one or more risks. So sometimes you can, you recommend some sort of validation. Try to have some sort of validation that protect against different input validation related threats and so on. Never forget detective controls. Okay, sometimes we focus just only on preventive controls to avoid some attacks and have some controls against those attacks. Never forget detection controls. This is very important. Very important to have full visibility in your application. Try to recommend some specific logs to be taken from some logical or some functional requirements in your functional applications, functions in your applications. So for this transaction, I need some sort of logs. Those logs could be used by the monitoring team, the SOC team, to build some use cases in the SIM solution, for example, where they have full visibility about some potential threats against your application in the production. So detection control is very, very important. OWASP logging cheat sheet and other, there is OWASP app sensor projects, very, very important. Actually, they define some detection points that could be implemented in your application, inside the application code itself. So a number of response actions could be taken based on those detection points. Those are very important as well. Microsoft threat modeling tool mitigations, they provide some sort of library for that could be utilized to identify some domains or controls. Actually, they have some domains. For each domain, there are a number of controls that could be used. Again, this is good as like source for such controls in your application. Okay, last thing, we finished now threat modeling. We identified all assets at the business services. We do threat identification, threat analysis, and everything. Recommended or controls. So I need to add a last slide here. I know we have pretty limited time. So about some very important topic related to the skills required to do application threat modeling. This is usually the question that we face during any application threat modeling exercise. As you can see, it's mixed between some information, some skills that require to understand the application component, the application deployment model, DevOps. Maybe you need to have some understanding for the entire application software development lifecycle, and also require some security skills. I highly recommend PASTA methodology. PASTA, they have RACI matrix. In this RACI matrix, they identify some roles in your application in development lifecycle, and for each role, there is specific requirement that they can provide. So it's mixed between some development, understanding for your environment from application perspective, and also some skills related to security. So again, RACI matrix is good, and in general, you need to have skills from both even developer with security background or security from the security team, where he understands exactly the internal application and the environment in your development environment. Okay, sorry, I have a very tight time. So this is all tips and tricks, 10 of 10. We finished all tips and tricks. Please, if you have any questions, please let me know.